James Clerk Maxwell. Please welcome Tom Bearden.
Thank you very much, Tom, and ladies and gentlemen. It's always a great pleasure to come to the USPA Annual Symposium. It's just like coming home. And so it's really nice to be back here once again. I'm sorry I didn't make it last year. I'll try to do better next time. Tonight I'd like to go into some work that I've been doing in the last year. It will not be on weapons. I'll indicate very briefly at one point the obvious weapons implication of what I'm talking about. But I would like to address the magic unified field theory that everyone has been looking for, how to unite gravitation and electromagnetics in a single theory that is engineerable, that can be used on the laboratory bench, and it does indeed work. I will try to indicate for you exactly what gravity is and exactly how to manipulate it electromagnetically. And I'll also indicate for those of you that are very sharp, rather precisely, how to easily make anti-gravity. Everything that I'm saying has a basis on the laboratory bench, but I work with inventors. So I will not present a circuit. I will not present even a picture of a particular piece of equipment, nor will I answer such questions. But the principles that I give you, I will assure you, you will have little problem yourself in applying if you're an experimentalist. And I will also assure you that they do work in the laboratory. And if all goes well, and the good Lord's willing, and the creeks don't rise, like we used to say down in Louisiana, in about a year or less, we hope to present the proof of everything I'm saying in livid, breathing Technicolor. So without any further ado, if we can get the mechanical part going, we will start to talk about what happened to this magic unified field theory that was the original theory of James Clerk Maxwell. Maxwell's original theory is no longer taught in Western universities, hasn't really been taught since 1900. Instead, the work of a single man who, quote, translated, unquote, Maxwell's work into the modern version of vector analysis, Oliver Heaviside, is what is taught as Maxwell's theory. It is a subset of Maxwell's theory that is taught today, and specifically it is that subset which only applies when there is no interaction whatsoever between the gravitational field and the electromagnetic field. We're going to show you the other part that got left out. First of all, the original theory, the first paper that Maxwell wrote, was written in 1864 during the time of the American Civil War. It was a unified field theory. It did contain an engineerable and workable and experimental theory of gravity, but very few people recognized it for what it was. Maxwell recognized it as the stress of space, but didn't understand that he had also grabbed a hold of gravity itself. And so, because it was written in Quaternions, vector analysis not having been invented yet or finished, it was written in a mathematics that was quite difficult to calculate in, and one which had very bizarre appearances of minus signs when intuition said there shouldn't be one there, and one which was devilishly difficult to calculate in, one which most scientists found quite distasteful. A quaternion differs from the present modern vector in that, in addition to the three vector components, you have a scalar component. For example, let us take a vector A. Obviously, the vector A today in a little normal sophomore physics will start out with A sub I, or AI plus BJ plus CK, where I, J, and K are unit vectors orthogonal to each other. If we take such a vector, for example, and we cross it with itself, we will produce a zero vector resultant. Now I want to stop right there. Let me say that again. Rigorously, we will produce a zero vector resultant. Now the two vectors didn't go anywhere. They're still acting upon each other. They're still there. So very rigorously what we produce is a zero vector system. That is, a system of acting vectors which sums to a zero resultant vector for translation. On the bottom, we show the same situation in quaternions. The quaternion is expressed very similar to the vector, except it has this little scalar term, W, sitting in there, with one big difference. When I cross, for example, Q, the quaternion with itself, I do not get just a zero vector. The vector part still goes to the zero vector resultant. But now I have suddenly the emergence of a scalar part, which did not go away. And the scalar part, it turns out, is in fact a function of the vectors that entered into the interaction. Notice on the bottom line that the cross product now is the square of the amplitude of one of the vectors. That's the urgency, or the energy of the urgency of one vector on the other, stress-wise. And I've retained the zero vector, because now we have to learn to read that exactly, which is what Heaviside did not do. What this equation says, and says very rigorously, is this. If these are two electromagnetic vectors or quaternions we started with, suppose they are the E fields, and the two E fields, for example, the two E vectors are identical, and we have an operation that's making the cross product. Suppose that's what's actually going on. What the bottom equation rigorously says is, electromagnetically, you have a zero vector resultant with the system of two vectors still inside the zero vector system and still acting, producing the action A squared. Now, A squared is proportional to the energy of one of the vectors, the amplitude energy, the urgency, so to speak, energetic urgency of one vector on the other. So we've captured a form of stress. And now suppose, for example, we're instead of dealing with static vectors, we're dealing with actual sine waves. Again, our Q cross Q is going to be A squared plus the zero vector resultant electromagnetically. I've got to say all that because I must not throw the zero vector away. It's a real thing. It's a vacuum engine, as a matter of fact. It is not a zero, except electromagnetically, but it's doing something else in the vacuum. Suppose Q is of the form, Q is equal to A sine omega t, standard kind of wave, simple sine wave type entity. Then Q cross Q will give you A squared sine squared omega t plus this zero vector. How do you read that? The way you read that equation rigorously, you don't throw the zero vector away. It's telling you something. It says I have a zero vector electromagnetic system whose active internal structure is giving me a scalar wave, A squared sine squared omega t. That's precisely what that equation says. Now, when you threw away the quaternion scalar part, you threw away the scalar wave, and notice that in the scalar wave, the energy, which is proportional to the A squared, is rhythmically varying. If the energy density of the local vacuum where this action is occurring is rhythmically varying, then rigorously, that is the definition of a local gravitational wave. And there is your precise definition or derivation of scalar electromagnetics. I will say one thing in passing and go on without further explanation because it takes a long time to explain it. That particular wave, the sine squared wave, scalar wave, is most useful indeed in electromagnetic healing. It has the unique characteristic, if you will break that wave out and look at it on your little graph plots, It has a most unique characteristic that almost no other wave has. A very weak wave of that exact configuration will instantly spread throughout the whole body, through the bone cells, through the marrow cells, everywhere. It won't miss a single thing. Okay, let's take a look now we're not going to get too technical here. I just want to give you the concepts and the ideas, and the mathematics we can all manipulate later. Actually, I'm not the only person in this room who's working in this area by far. I'd particularly like to mention the very important work of Dr. Henry Monteith, who, as far as I know, independently discovered the same thing, because on a telephone conversation, he was telling me about it and I was telling him about it at exactly the same time. And Dr. Monteith has already gone much further than we'll go into tonight on the mathematics of the whole area. I expect probably that the full theory of scalar electromagnetics will probably eventually be written by Dr. Henry Monteith. Now, what can you do with an electron? Well, you can push the thing straight away. You can produce a field that will do that. That's what we call an E field. You translate the electron straight away, or the charge. That's the definition of an E field. Another thing you can do is you can produce a field which will cause the electron to interact with it and swirl around in a little swirl. That is technically what we call the magnetic field, the B field. There's one other thing you can do. Suppose you do not move the electron at all, but you have a zero-vector electromagnetic system. Remember, now I've got to say some extra words. I can't just throw away the zero vector. I've got to go after the gravity that's left when it's there. If I have a zero-vector electromagnetic system, it's a stress system, as I show on the bottom diagram. Suppose all of those vectors are rhythmically varying, like a sine squared or a sine wave. I have then a scalar wave, and all that it does is squeezes the electron. Can we not easily imagine taking a rubber ball between the outstretched fingers of both hands and rhythmically squeezing it and relaxing, squeezing and relaxing? That is a scalar wave. Specifically, it does not translate the particle, neither does it swirl the particle, it merely squeezes it. So it does not give you an electron wiggle. And electron wiggle detectors will not detect it, because they detect translation fields, E fields, or swirl fields, B fields. They do not detect squeeze waves. As a matter of fact, that squeeze wave doesn't do much to the electrons in the shells and orbits around an atom. It goes through and is absorbed and interacts with the nucleus, as we'll see later. To show you that indeed Maxwell knew that he had captured the stress of the medium. Now remember, he wrote a theory based on a mechanical ether. The ether was a thin ethereal material in his model. So when he says a stress in the medium, he means a stress in the ether. And he knew about that. And here's a direct quote, which you can read from the chart, directly from Maxwell himself. Here is the finish of the quote. Again, directly from James Clerk Maxwell. So Maxwell himself realized that he had also captured the local stress of the medium in his full theory. What is really pathetic is they didn't realize that's what gravity was. So Maxwell had written what really was a unified field theory of electromagnetism and gravitation in Quaternions, because he had captured the stress or the squeeze wave in the local vacuum. The fluctuation or the variation, controlled variation, in the local energy density of the vacuum. Heaviside, later on, in fact, after Maxwell's death, was one of the two men that finished what today we call vector analysis. Heaviside and Gibbs. Now, Heaviside's solution to the formidable and teeth-gnashing problem of calculation with Quaternions said, the real problem is you're mixing apples and oranges, and so what we got to do is get rid of the scalar component, and he just sawed it off and threw it away. One single human being, Oliver Heaviside, did that. Nobody else. Not a team of scientists, not a board of peer review, one guy. Remember, there are very few scientists at this time. Probably there were some 30 or 40 scientists in the world, in the Western world, struggling with electromagnetics at the time. That's about all you had, not many. There was a short debate then. Remember, Maxwell is long dead. The Quaternionists were pointing out that you have not captured the complete theory, and the vectorists were saying, yeah, but boy, can we calculate. We can out-calculate you all day long now. This is simple. It's easy to understand. We got it. They had a short debate. Most of the action occurred in the journal Nature. They simply buried the Quaternionists. That's all there was to it. And by 1900, you couldn't even find Quaternion theory being taught anymore. Everything was now Heaviside's version of electromagnetic theory. Now, what happens when you throw out the squeeze wave? When you throw out the scalar component of the Quaternion, you throw out the component that caught the interaction and interplay between electromagnetics and gravity. Now, this caused Albert Einstein to make a most serious and grave restriction, and today we would call it an error, on general relativity, because Einstein studied Oliver Heaviside's version of electromagnetic theory. And in that theory, you do not and cannot have electromagnetic curvature of space-time. Let's reason together, ladies and gentlemen. Let's make this as simple as possible. What does a normal garden variety Heaviside electromagnetic wave do? It gets the hell out of there at the speed of light. It does not stay around and oscillate the energy density of vacuum. Blip, and it's gone. It's the fastest thing in the universe that's a material type thing. But what does a squeeze wave doing, which is sitting in position and squeezing? It sits there and it oscillates the energy density of the local vacuum. The gravitational wave is what it is. It doesn't go anywhere. It doesn't take off at the speed of light. It's sitting in place. It's all locked together as a single system with a zero vector translation, or get the hell out of there result. So Einstein then, not knowing any way that you can curve curve local space-time electromagnetically, and by the way, all curvature of space-time means, that's a simple thing. Imagine that space is filled with little fantastically dense and intense spray all the time, called a virtual particle flux. The only problem is each little particle doesn't stay around. It's instantly born, almost instantly dies. So it's like a gas that's continually, each particle being continually created and annihilated. So it's a crazy kind of gas, flux, that we're looking at. That's really the modern view of the vacuum. And all we're talking about is the intensity of that flux is oscillating. That's all we're talking about. Only we polarize the internal pattern of it. We can put patterns in it. That's what the stress wave or the scalar EM wave is. Einstein then said the only other thing left to curve local space-time is this very weak gravitational force, which is some 10 to the minus 42 times weaker, or down in the grass, from where the force, the electromagnetic force field, the electric field is between two electrons. Now that's very weak. 10 to the minus 42 is a very small fraction. You can't find that. You can't even measure it with normal instruments, with great difficulty. So he reasoned then that that's so far down in the grass, you're never going to be able to measure any kind of local space-time curvature from that, from the electrical stuff going on. He also reasoned that such a thing that you could measure could only result from a huge collection of mass, like the sun or a great star or something like that. Well, the laboratory and the instruments and the observer and the researcher is not going to be sitting on the surface of the sun. It's a little bit hot. So he said, therefore, where the local observer is, where the lab is, where the instruments are, there will be no local curvature of space-time. So he assumed, because of that the local space-time is never curved. Now, all you energy buffs, clean out your ears and open them up. Wake up and listen. When you make that assumption, the local space-time is never curved, gives you Lorentz frame, all that nonsense. You now save and cause to be applied rigorously every conservation law. In that system, you cannot escape the conservation of energy. You're not going to get any energy from space-time. It's all going to run right back in there that you get out of there. You're going to lose it. So forget any kind of a free energy device where you're trying to build a paddle wheel in a special river, as long as that assumption of Einstein holds. Now, if you were to curve local space-time, the Russians have long since removed that restriction from general relativity that they teach. In the Western world, you can't get such a paper published in Western literature. Many good physicists have tried. If you curve local space-time, and this is absolutely rigorous Russian work, check the leading journals and the leading academicians, all, I hope you heard that word, all conservation laws go out the window. There are no irrevocable conservation laws when you have local curvature space-time. And that's the thing, the condition that Oliver Heaviside threw out of James Clerk Maxwell's original theory. He threw out the baby with the bathwater. But he made it a hell of a lot easier to calculate and understand. So people began to understand it, began to be able to calculate, began to build instruments and make great advances. But meanwhile, we had a severely crippling assumption made for good reason by Albert Einstein on general relativity. And the irony of all ironies, for the rest of his life, Einstein was in a vain and desperate search, trying to find out how in the world to get electromagnetics back in there, and he never succeeded, not realizing that that little bitty assumption meant you could never do it. If he had changed that one single assumption, he had it all. And if he had studied Maxwell's original Quaternion theory, he would probably have not made the assumption, and you would be flying anti-gravity spaceships all over the solar system since about 1904. Okay, we have a new breed of cat now, the scalar EM wave. It's rigorous. You can mathematically derive it. You can try it out on a lab bench, and it works. But it works quite different from normal electromagnetic waves. So all you electrical boys, got to remember now, you got to learn some new phenomenology. They didn't teach you this one in electrical engineering. And if you look at circuits that work this way, and you insist you're going to look at them with electrical engineering eyes, you're going to go home thinking that that can't possibly work and it's all nonsense. And you will never, never be able to build such circuitry and such devices. You've got to learn to think in a different manner. In the first place, this wave goes right straight through the electron shells, goes down the nucleus. Well, we're going to tamper with something very fundamental here. Let's ask a very fundamental question. What is this physical reality around us? How is it made? Everything is made from potentials according to quantum mechanics, the most modern theory. Now, operators, forget your force fields, your E field and your B field. That secondary jump that comes after the operator works on the potentials. The potentials are gravitational fields. Gravitational potentials, all potentials are. But this normal thing you studied is the normal electromagnetic wave, the E field and the B field component, normally reacts with the electron shells of atoms with negative charges. Why? Because all the atoms got the electrical charges negative around them in their electron shells. The whole world is built that way. Now, the electron shells can go bananas. A lot of interaction. The average nucleus is several 100,000 times more massive than one electron, which interacts with one photon. So the big old nucleus just sort of shakes a little bit in most cases, and that's it. So large assemblies of nuclei, of atoms, normally very stable. in this first-order reality stuff. Physical reality as you normally see it. You're looking with electron wiggle detectors from your physical system, and that's what you're seeing, photon interaction with electron shells of atoms. And so the world is very stable. And all of the people first start off thinking that become materialists. They think everything material is real, and that's it, and that's ultimate reality. And a lot of them are willing to kill you under certain dogmatic systems to enforce that belief. And nothing could be further from the truth. That is a first-order truth, but it is not ultimate truth. This thing is real, but it's not ultimately the only reality. If you go down into the nucleus now, and you really hit the nucleus, if the nucleus moves, everything goes bananas. And the stable order that you observe around you goes right out the window. And when you go in with the scalar waves, that's the kind of reality you're looking at. Okay, let's talk about the flow of time, because we're going to tamper with that too. I told you this part gets a little complicated, but I'm going to try to show you, before you get out of here, how to think about a time reverse wave, and how to use it, and how to make it work for you and do magic. Now, a photon comes in and interacts with a negative charge, and then the charge goes into excited state going around the atom, and then drops back and decays and emits a photon. That process of photon absorption and emission, re-emission, from the excited state of a negative charge in an atom is what we call the positive flow of time. Now let's be rigorous here. We're saying that the flow of time in this universe occurs bit by bit at a fantastically high rate, one near piece at a time. Delta T is not always the same size. It is discrete, but it is not the same size. So watch your words. You've got to think very carefully. Chronons do not exist, not as being one simple value. It's discrete, but it's quite variable, as we'll find later. If that same photon interacts with a positive charge, we already know in physics that if you invert the charge, you invert time. That may surprise you, but it's well known in physics. That is not Tom Bearden. And so it gives you a little piece of negative time. Hey, wait a minute. We got a problem here. They use a theorem in particle physics. They found out that charge is not conserved, broken symmetry. Parity is not conserved. Time itself is not conserved, but it seems that the product of the three, all three, cannot be violated at one time. That's the best shot we got at it today in particle physics. That's where they're at. But you can violate any two, or one. Let me say that again. You don't have to conserve charge. The contrary argument is, but it's a little effect. You say, yeah, baby, it's a little white crow, but maybe he'll grow. If I can have little white crows and I can collect them and grow them, I'll have big white crows in the macro world. So charge parity time, if you inverse the thing, you might get something different. As a matter of fact, the antiphoton, which has been assumed to be the same as a photon, that is a false assumption in physics, and I'll show you that in just a moment. Well, we've already said we go into the nucleus with scalar waves, and we'll have a higher order reality when we do that. Why? First place, we're interacting with a positive charge. The nucleus of an atom is already time inverted. Did they forget to tell you that in your electrical class? Yeah, because they didn't know that. But it's true, and modern physics substantiates it. And we're going to find out that's why we're going to get time reversal waves a little later on that we can use to do all sorts of magic things. At this point, then, if you go into the nucleus, although I show here on this diagram little balls all clustered together, modern physics tells us that's not the way the nucleus is built at all. It's a vast boiling smear. There's not a proton, there's not a neutron, all that mess in it at all. If you go in there and you catch one and you gradually catch all the wiggling fish and bring them out, that's what you'll find on the average after you stop the fish. But before you stop them, they're waves. They are not particles. They're all mixed up as a big mess. So you can't separate them. It's a boiling mess. In fact, it's a trapped local potential, which means it's gravitational. That's what mass is. That's modern physics, not Tom Bearden. But now, if I can go in and have a wave absorbed directly in that, the scalar wave, I just either increase or I can decrease depending on how I bias that potential wave that I send in there. Then I can raise that potential and lower it at will. As a matter of fact, if I keep radiating it and absorbed in there, it'll keep building up. It charges up just like a capacitor, only now it'll charge either positive or negative. And I'm giving you laboratory results. It acts as a capacitance for scalar waves. Now, when something else comes in there and hits it another wave, it'll trigger the thing, it'll collapse, and out will come another wave out of the nucleus. There'll be a time-reverse wave, and all the nuclei in the universe are continually exchanging scalar waves. I don't have time to go into this aspect, but I will say with the fourth law of logic, which I built many years ago and proved, I published a proof for it, so I don't have to worry about can it be proved. I can demonstrate it in less than 10 seconds. The fourth law of logic tells us ultimately you can only model a thing in terms of its direct opposite. It's not geometry, the modeling of the presence of mass in terms of the absence of mass. You see my point. In this case, we're going to have to learn a little bit of that in our modeling theory, and we'll go into that in just a moment. But when we go into the nucleus now in this boiling mess, and we can actually adjust the potential, we can even put patterns. Remember, we put fingers, structure inside this scalar wave. It's got a structure. We can build any kind of zero system, different systems and patterns and polarizations inside there in the virtual state of vacuum that we wish to. We can go into that nucleus, and it's boiling away. It's just like a cathode. You put a little signal in there, you put a matrix. That thing will organize. You know about Prigogine, you know about self-organizations of highly nonlinear systems far from thermal equilibrium. That thing is as far as you can get from thermal equilibrium. It's a violent exchange with the vacuum itself, virtual particle exchange. It's a Prigogine system, first class. And that thing will self-organize according to the pattern you put in it. I've just told you how to do transmutation of elements. Between isomers is very simple. That man was nominated for the Nobel Prize, Kervon, in 1977 for proving conclusively that living systems with microvolts can transmute elements to a limited extent. Chickens do it, we do it, oats, barley, rye, wheat, everything does it a little bit. And the average biologist still hasn't heard of that and doesn't believe it when you tell him. But it is a fact and it was replicated. And that's how it's done. The living system can generate and has these electrogravitational waves, these squeeze waves, these scalar EM waves, the part that Heaviside left out. Living systems have generated since the beginning of time. It's very weak as far as power goes, but if you keep right on pointed into the nucleus, you can change the nucleus. The nucleus will order and change and charge up with that pattern. That's how it's done. And it's fairly simple to be done between isomers of the elements, of the isotopes. General relativity and Kaluza-Klein geometry now apply, because when you go into the nucleus, you've moved into higher dimensions. How many? As many as you wish. But you've got to have at least 5 dimensions to capture a unified field theory of gravity and electromagnetics. Now, when Heaviside threw out the scalar component before 1900, it meant that somebody could come along now for special relativity and put it in 4 dimensions. But did he have electromagnetics in there? Nuh-uh. No. You can't really fit electromagnetics correctly and have gravity in there too in 4 dimensions. If you have a 4-dimensional theory of electromagnetics, you ain't got gravity. If you've got gravity in there, you ain't got electromagnetics. It won't fit. But if you'll add 1/5 dimension, which Kaluza did in 1920s, you can unify, again, electromagnetics and gravity. This paper was published on the recommendation of Albert Einstein. So now we must have Kaluza-Klein at least 5-dimensional geometry. By the way, Kaluza showed that where the extra dimension went, you could model it as wrapped around each point in our 3-space. Now, in that model, electromagnetic waves do not travel through 3-space. Rigorously, they slither around the little surfaces around every point in 3-space along their direction of travel. That's a quite important distinction. If they penetrate the point, that's gravity. If they slip and slither around it in the fifth dimension, that's electromagnetics. And that's Calusa Clown theory, not Tom Bearden. They just don't make it quite that simple and clear. What do we got here? Guess we got a space. Now, in the past, I've given you a piece of information because I didn't want you to hurt yourself. I gave you spatial opposition of positive energy, positive time waves. And those are very weak. You get very weak gravitational effects and very weak inertial effects. You won't kill anybody with that, and you won't kill yourself. But this one is powerful. Specifically, it can be 9 times 10 to the 16 times as powerful. You make a time-reversed wave, which we're going to go into with a full explanation here. You're going to get the full treatment tonight. I'm not going to cut it short. If you get tired, just go. If you want to get it, stay, because I'm going to make it real simple. But if you take a normal wave, which I've shown as little sine wave here, one oscillation, and you make its time-reversed or a time-reversed replica, it's exactly like it in space. It fits exactly with it spatially, but the time dimension is reversed. Now the stress of those two waves, that they're locked together, is totally on time dimension. That's a highly compacted space dimension. And you get one going up, one coming back, so you get a c-squared type factor out of this thing. That gravitational wave, and that's what it is, that scalar wave, can be up to 9 times 10 to the 16th times as strong as the one I've told you about in the past. And this is the one you do if you want to do anti-gravity. You got your ears open? You listening? All you have to do anti-gravity, all you want in any university laboratory in this country is make a pumped phase conjugate mirror at 100 to 400 hertz. Let me say that again, and I'm not going to answer any questions on it. All you have to do, if you want to make all the anti-gravity you wish to make, and any university laboratory in this country can do it, it's simple, doesn't take much power, is make a pumped phase conjugate mirror between 100 and 400 hertz. Enough said. Okay, a photon is a piece of energy and a piece of time welded together with no seam in the middle. It's a piece of what we call action, which has the dimensions of angular momentum. We usually show that as Planck's constant h. Aha! H is always positive. You've got to have something called a brick called action, but the brick can be made 2 ways and still be positive. You can make it with a piece of positive energy and a piece of positive time you weld together, and the product is still positive. You can make it with negative energy and negative time, and it's still positive. Now, the first one is a photon, and that's something that comes off of interaction with a negative charge, and it'll give you positive time interaction as it continues. It'll also give you entropy, because that will tend to more and more disorder. And the law of entropy, the second law of thermodynamics, ruthlessly applies. Now, what's the assumption in that law? Your professor never told you it had assumption, because he didn't know it. The assumption is it's only for positive time critters. It does not apply to negative time critters. The negative of the law applies for negative time critters. It backs up. Instead of tending to more and more disorder, it tends back to order. So don't you worry about the universe running down. It's running back up to order just as fast as it runs down to disorder, but in negative time. But the internal part of every atom is already filled with time-reversed critters. Now, the energy of an atom, of a photon rather, is E equal h nu, where nu is the frequency. Let's reason together here. Why did I say we got plenty of people making pumped phase conjugate mirrors, and these guys don't ever see anti-gravity? Why? I just told you you can do it that way. Am I a fool, or did they miss something? If you understand that equation, is it not true if H retains a fixed size, it can't vary in size? If I have a big delta E, I'm going to have a little delta T. Magnitude of, if negative delta E is big in magnitude, then negative delta T is small in magnitude. They are canonical variables. Well, if you've got high frequency by the bottom formula, you've got lots of energy in a photon. You've got very little time change in it. So high energy photons, high frequency photons, are not going to have very much negative times, even when they're antiphotons. They'll have very little, and anti-gravity depends on negative time. Let's reason together. If in positive time, the assumption in Newton's crazy little old gravitational law, attraction of mass, what's the assumption? Positive time. Anybody ever tell you that? No, because they never thought of it. But if you reverse the time, do you not back up the situation? Does now mass not repel? And we have just told you can go into the nucleus and start charging the nucleus with a pattern including negative time. We have just told you that you had to use low frequency. Why? Because you want a big delta T. You don't want a big delta E. Delta E gets in your way, tears you up. So the optics boys never see this. That is so far in the grass you can't even measure it where they're at. They never thought about doing it at 400 hertz. You go home and try it in your laboratory. And then sit on the side laughing for the next 2-3 hours. And how silly we all been for years. And how easy it is to do it. I will tell you, if you pursue that, you can take a flashlight battery and levitate a battleship, and I will not discuss that further. Because then you're going to ask me about the Philadelphia experiment, and I'm going to tell you I don't know anything about that. Once in a while, I've got to lie a little bit. Unfortunately. Okay, as delta E goes up, delta T goes down. The magnitude, the absolute value. We're going to be interested when we talk about gravitational, inertial effects, things like that. We're going to be interested in big pieces of negative time, low frequency photon. Stay away from the optics, boys. They're in the wrong regime. They're doing good work, but they're in the wrong regime. Let's see then what happened further with some of this. Well, comes along the greatest electrical genius of all time, Nikola Tesla. What does Tesla do? He discovers the scalar EM wave. He called it his standing columnar wave. Let's run that by again. Standing columnar wave. Does it make sense now? A squeeze wave which stands in place. He discovered that out in Colorado Springs before 1900. He has such a rapid progression of his understanding of this and his development of material. He also discussed time reversal. We'll get into that later. He found that out. He started building on Long Island a situation to power the whole world. And tonight I'm going to explain to you precisely and exactly how that works. And I'm going to tell you there's 1,000 papers in the literature that prove the fundamental mechanism works. And if you believe you can get that mechanism in the earth, then you have just shown that it will work. Well, Dirac put in time reversal. He didn't predict a positron. He predicted a time-reversed electron. And lo and behold, they looked around and they discovered the critter. So all of a sudden, we had time reversal in physics. Only we reversed the whole particle. Nobody's doing the photon. Now, because they said, well, you time reverse the photon, it wiggle this way or wiggle back that way, it still looks like a sine wave, same thing. And they missed it right there. Kaluza-Klein theory came along in the 20s after general relativity had come along we talked about. Gravity and anti-gravity were worked out based on only the attraction of mass. Electromagnetics is left out. That's the missing ingredient. Everybody's hunting for how to get it back in. Einstein failed in his vigorous search for it the rest of his life. And the reason was they didn't worry about negative energy, and they didn't worry about negative time. How many physicists have thundered about the second law of thermodynamics, and not a damn one of them has realized that it assumes positive time only. It does not assume negative time, time-reversed critters. Well, a magic thing happened in World War II. Now we're going to tell you some of the rest of the story that we haven't told you before. In World War II, a funny thing happened. Radar came into being, and everybody's using radar like mad. The German wolf packs were murdering the ships. When we put the radar in an airplane, we found out you could track the periscope when the U-boat came, stuck its eyes up to look. When he put his snorkel up to breathe, you could track his snorkel. And all of a sudden, we had a hunter-killer team, and we were bombing the living hell out of those U-boats. And the pride of the German Navy went to the bottom. Boom! And 1 month went by, they didn't sink a single ship. And they lost a hell of a lot of U-boats, because every time he looked, boom, come greetings on his head. In an absolute panic, the Germans placed the finest brains, and they had the finest brains in those days in Europe, the finest mathematicians and the finest physicists and the finest brains on that problem. They originated what today is really called rigorous radar cross-section theory, radar absorbing material. They advanced radar cross-section, which is the heart of modern radar theory and countermeasure theory, further, according to some real radar expert friends of mine, than we are today. Just a little further than we are today in the U.S. And at the end of the war, that entire team went to the Soviet Union. Again, let us reason together. What do you do? They coated, by the way, their snorkels with the RAM material, and they coated their periscopes, and thereupon they didn't get any reflection back, and so we couldn't track them again. They went right back to shooting down or torpedoing the ships. Okay, let's reason together again. What do you do with the radar-absorbing material? It's in the open literature. You do something like carbon doped with various materials, and what you do is you slow the wave down till you can get at least a whole wavelength or the correct portion of a wavelength in there, and what you do, reflect back, you get it out of phase, canceled. Make that zero vector, right? Electromagnetic zero vector. You don't have no electromagnetic reflection. They don't wonder about it or try to detect it or have any detector if it's a gravitational reflection. So it disappears off your radar. Still sitting there, still absorbing the energy. Now, you will find out later that when we absorb two waves in a nonlinear material, 180 degrees out of phase, that's called a pump wave. And that's the first thing you do to start to make amplified phase conjugate waves. You start to get anomalies when you radiate with another wave. Bang! You get this big amplified response. Boom! Comes out of the material. Why? Where the devil did that come from? Not supposed to be there at all by electromagnetic theory. When you radiate such a material with multiple beams, you have what today is called pumped phase conjugates, four-wave mixing. And you get amplification of the tickling wave, and you get high amplification of it, and you get it with a time-reversed wave, as we'll find out later. I'll show you how that works. So the anomalies were there. Now, in Huntsville, Alabama, we have the head of the rocket team, retired, Dr. Lange. Dr. Lange knew those members of the German radar team, and he has confirmed they had anomalies. But after all these years, he doesn't remember what it was. He had his hands full with big rockets. We got the rocket team, you see. But it says that the Russians had those kind of anomalies that led to pumped four-wave amplification of time-reversed waves in radar at the end of World War II. And by 1950, they built in operational radars. They've got the finest mathematicians, and always had the finest nonlinear mathematicians on it. And they started that whole weapon system in radar by 1950. And they got it from the German radar team. They did not start it in nonlinear optics. Now, we were not clever enough or smart enough to discover the time-reversed electromagnetic wave. After developing all the formidable weapons I've talked to you in the past about, around 1969 or 70 or so, the Russians cautiously released this stuff, a paper showing the time-reversed wave in the optical frequency. Why? Why in the optical frequency? They didn't want you to get anti-gravity. Hell, if they'd have released it at 400 hertz, you'd have had anti-gravity already. So they didn't want you to have that. Stay away from that. Go up there where it doesn't harm anything gravitationally and see if we know about it. We showed we didn't. Nobody reacted. So they sent a couple scientists down to Lawrence Livermore Laboratory and briefed them on it in 1972. This is time-reversed waves. And our guys, with great alacrity, said, aha, methinks there's something here. I've been hit over the head with a brick bat. So they started vigorously working it in nonlinear optics. It's a general solution to the wave equation. Now, we haven't got the foggiest notion today what generates a time-reversed wave, but boy, do we know how to write an equation. We take the wave equation, write an asterisk in one term. That's it. That's all of it. It writes a time-reversed wave. So we think we understand it. We can write the equation. We can solve the equation. Haven't got the foggiest notion what causes it to be born, but if it is, it'll follow that equation. That's where we are today. We're going to go further than that because you need scalar electromagnetics to go further. A couple of more technical things, then we'll get into fun cartoons. World of change is composed of action, two canonical variables, energy times time. I just wanted to refresh your mind here, and we can have either negative or positive. Now, I want to show you how it works in Kaluza-Klein theory. Everything comes in 5 dimensions. The potential is really in 5 dimensions. But this little surface around every point in our space-time, as you shrink to a point, does not the surface area vastly increase? Isn't that the law, that the surface area around the volume increases the smaller the thing gets? By the time you get down to a point, you've got a real humongous surface area for electromagnetics to slip around and not have to penetrate the point. So everything escapes electromagnetically real easy, slips around a 5th dimension. Never penetrates, never makes gravity. So electron gets it and boogies out of there. So most of the 5 dimensions is normally bled off on the left. As fast as you form the potential, which is a 5-dimensional pressure, so to speak, zip, boom, it's gone in the 5th dimension, electromagnetics, and that's all there is to that. So, if you can force it to go into the 4DG field, you got to first block this terrible escape. For example, between 2 electrons, only 10 to the minus 42 of it gets out as gravitational, actually penetrates the point. But if you could block that arrow on the left and force a lot more of it to go over there into the actual 3 space that's in our 4D Minkowski space, then you get lots more gravity, lots more inertial field. That's all you got to do to build an inertial field generator. But you got to block the EM field. How are you going to do that? Well, you do it real simple. Normally it goes boom out there as electromagnetics, not much left of gravity, a little bitty tiny hiss over on the side to make it kitty cartoon but impress the point. But if you block the escape as electromagnetics, block the big door, you'll get a big boom out over there, and you'll get lots of inertia and lots of gravity, and you can engineer that on the bench at will. The great cosmic engines of the universe operate inside vector electromagnetic vector zeros. That's where the gravitation is. Gravitation is enfolded electromagnetic forces locked together with a 0 E field and B field resultants. Electromagnetics is the outfolding of the locked-in electromagnetic stress of the vacuum. That's all it is. And by the way, that's rigorously in agreement with modern physics, except we can have a structure to it, whereas they normally have it as a random structure. They don't use the fact that you can deliberately do it, because why? Heaviside taught them to throw away the 0 electromagnetic vector resultant, because he had thrown away the gravity with that system. Okay. To get distance effects, we all know how to put photons through there and hit something out there at the distance, or hit it with matter, but the best way to do it is to do it with potentials, not with force fields and photons and matter. And that's potentials. Potentials were thought to be mathematical figments until quantum mechanics proved they are the real things, and it's the electromagnetics that's a derivative. And interference is what gives you everything in the potentials. That's the magic. First, you got to make potentials. If you make these, the 0 vector electromagnetic systems are artificial potentials. They have an internal structure of stress, but they have no gradient. They're not flowing out with a translation vector or a swirl vector. If you interfere 2 of those at a distance, you recreate electromagnetic energy. Depending on how you bias the beams, you create the thing higher than the normal energy, so energy flows out of that interference zone. If you bias it lower, it'll create energy lower, so it'll suck energy out of there. And by the way, it'll come right back down the beams, back in your transmitter. You better dump it somewhere. But let's look at some characteristics now of time-reversed waves, because here's where the real magic is. This is the magic we've been looking for. We'll go at it first like the nonlinear optics boys. If you have a piece of plastic that's nonlinear, hunk of junk, 10-cent piece, and coming in from the left over here is the dotted line, a wave front that I show as E1. It comes in and it strikes this nonlinear medium, and it travels on through it, and it starts getting distorted as it goes through. The wave front starts getting distorted because it's a nonlinear distorting medium. It comes out the other side, and you see it's now all wiggly and distorted. But another magic thing happens, which we didn't know. We had to discover it from the old Soviet literature, and then they had to kick us in the ankles to get our attention and make us realize what they'd said. And we went to work on it. The medium also generates a second wave that's a time-reversed wave, E2, that now appears spatially in phase everywhere that other wave appears, forward, backwards, everywhere else. It's normally a very weak thing. We'll find out you can amplify it real easy. But it is totally and exactly and precisely in phase. It has an invisible trace of where this other wave came from and where it's going, and it boogies out of there to appear right in that exact same place in space. But in time, it's reversed. It's a stress in time. The two together will form a real good gravitational wave if they're equal, spatially. They don't know that in optics because it's the wrong frequency. They never see the gravity aspects. They don't have it in optics. This is a quote right out of a standard textbook that says the same thing the diagram said, and I won't bother to let you read the thing. It says exactly the same, only very technical. Okay, let's amplify the thing. We take our same piece of plastic material, hunk of junk. We put in a wave A2 and a wave A1. Normal, nice garden variety electromagnetic waves. Nice little sine wave, let's play like. But we put them in so they're in a medium at 180 degrees. That sounded like that RAM material, didn't it? Only now I'm working at optics. Just wanted to point that out in passing. And so now in the medium, what do we have? Is it not a nonlinear medium? All you electrical engineers, is that not a modulator? Let's hear it. Yes. It locks the two waves together. They don't just mix and run through one another. They become one system. You've got to have a zero vector locked-in modulated system, not mixed waves. Mixing don't do it. It's got to be modulated. It's got to be a nonlinear medium. Okay, the waves A1 and A2 spatially, 180 out of phase now, do they not lock together and form a zero vector resultant? E field and B field. Yes, they do. Is that not a scalar wave? Now, you can argue a little bit if you want to about what happens to the magnetic field. If that bothers you, so it's going to shift 90 degrees, forget it. Just stay with the E field. The point is you can make a scalar wave, and it will go now into the nucleus, and they call the combination of those two waves the pump wave. And what are you pumping? The nuclei of the atoms in the material. What are you doing to the nuclei of the atoms in the material? You're charging them up to a higher or lower potential, an excited state as the case may be. Doesn't matter. And here you go. And then suppose you come in here with a little old weak A4 wave. These are the numbers that they use. A1 and A2 is the pump, A4 is the input. This thing operates like a triode. A1 and A2, the pump wave, makes the nucleus a cathode. A4 goes in on the grid. A3 comes out as if it were a signal coming off the plate. And you can have all the energy in A3 that you up to what you've got in A1 and A2. And A3 is time reversed, which means what? It means wherever A4 came from in the universe, out there from some distant point, this thing has a memory. And it takes off, boogieing through space, precisely fitting the path that A4 took all the way back to that point. Be it 6 feet in the laboratory, be it 6,000 miles away, or 600,000 miles in the perfect case. If that's an over-the-horizon radar, signal A3 boogies back up to where it bounced off the ionosphere, boogies on back over to where we tracked a rising rocket, like the Delta rocket in '86. If I am popping a pulse, suppose I put 100 megawatts, put whatever you want to, in A1 and A2 in a pump wave, I can get out up to 100 megawatts in wave A3. Do you see that? Does everybody understand that? Boom, out comes 100 megawatts in A3 in the oscillation condition. A3, 100 megawatts, now backs up. It does spatially the exact thing different from a normal wave. It converges along its trail, not diverges. All of the power goes right back the trail, right into the missile if it's slowly rising. And if you're 150 feet over to the side of the missile, you won't see anything. You'll think it originated inside the missile. And so the Delta rocket died with 2 mysterious surges of power in it that cut the damn booster off, and they had to destroy it. That's exactly what destroyed it right there. We'll talk about some other things later. Now do you see that this thing is useful for weapons? If you understand time reverse waves and phase conjugation, you can design yourself every weapon I have in Fairly Lance. And the words phase conjugation do not appear in the book by design, not by accident. And I can't tell you how many times I've been beaten up verbally and abused by physicists and engineers who didn't know what the hell they were talking about. And they didn't have the foggiest understanding of time-reversed waves. Now let's lay one issue to rest. The average physicist who knows about this, in the face of 1,000 papers already in the literature proving this, experimentally and everything else, theoretically, does not believe it's a time-reversed wave, even though we've described the characteristics. Oh, well, it's a wavefront reversal. We prefer to say it can't go backwards in time, you can't go into the past. Immediately he reveals his ignorance. Let's reason together. I said this wave was time-reversed. Did I say that every single particle of mass in the whole cotton-picking universe was time-reversed and backed up to a previous state of the universe, which is what the past would be? Nobody said any such thing. The theory doesn't predict any such thing. And if he thinks that's what I'm saying, he doesn't understand time reversal, and he doesn't understand quantum mechanics, and he doesn't understand physics, and he's put a label around his own neck and on his own forehead. Not me. He has done it. So much for Los Alamos and Lawrence Livermore. Yes, indeed. I have the papers. I have friends who send me the copies of letters of the names they call me. So much for Los Alamos and Lawrence Livermore Laboratories. Now, so we have a magic wave. In the real world, you have some change, like in the ionosphere, some distortion of the exact path itself, the medium, because there is a finite time involved, and so you'll miss a little bit. Maybe you get 90% or 80% of it in there. That's good enough for government work. That'll destroy the missile. That'll destroy a bomber running down, takes it off down the runway before it ever takes off. But this thing is magic, because now I can make a time-reversed wave. I want to give you a way to visualize a time-reversed wave and settle this issue of going back to the past. I want you to imagine a movie of scenes going on here. And in this scene, somewhere amongst all the surroundings and all in buildings and all this, there is a wave generated. Okay? And you're watching this wave go. You're magic, so you can watch it real slow, and you're watching it go. And suddenly we say, now that wave and that wave only is reversed in time. We can't see time. Quantum mechanics tells us it's not an observable. You can't detect it even in principle. What we will see is the spatial aspect. We will see it crawfish backwards, spatially. We'll see everything else continue. So what would I physically see and observe? I would see the whole rest of the world going along in positive time. I would see this crazy wave suddenly stop where it's time reversed and start to crawfish backwards and crawl back right along its path. Meanwhile, everything else is going on just like it was. That's all time reversal is. Think of it as space reversal. But it carries negative energy. And that's magic, as we found out, because you can get inertia and gravity from that. If you get down at the right frequency, optically, you'll never get it. Radar, you'll never get it. Okay, let's continue. To show you how strange a breed of cat this time-reversed wave is, I want to compare a normal mirror to a time-reversed mirror, a phase conjugate mirror, they call it. In the top one, I show you a standard mirror on the right, on the point source. The light from it scatters across the surface of the mirror and has the standard diverging pattern reflection. As I show that, it's optical geometry. Everybody knows that. Normal reflection. So if you're doing that, light scattering from the toe of your shoe across the mirror, there's one point where you get the right angle, comes to your eye, so you can see your toe, you can see your knee, you can see your clothes and everything, and you stand there and look in the mirror, and you're quite happy with that. Let's look at a phase conjugate mirror. The light from the source, which may be the toe of your shoe, scatters across the surface of the mirror. From every point on the surface of the mirror, it reflects right back to the original point. It crawfishes backwards, boogity, right back to the point. What could you see if you looked in such a mirror? Could you see your toe? All that light goes back to your toe. Because you see your knee. The only thing you could see would be the two black retinas of your eyes, nothing else. It's a quite different breed of cat. This is out of the standard literature about Pepper. That's not Tom Bearden. It's a quite different breed of cat from an ordinary EM wave, and you must understand that. It does not behave the same. And I want to quote Pepper on something else, because I want to point out to you there's a whole new physics here. There's a whole new world. Pepper said, the real and the major discoveries in phase conjugation and time reverse waves are yet to be made. So have at it, young fellow. There's 100 Nobel Prizes waiting on you. Anti-gravity, free energy, violation of all the conservation laws, control of it, overcoming space-time, moving in hyperdimensions, materialization, dematerialization, transmutation of elements, reversal of disease, reversal of aging, you name it, it's there. The absolute control of physical reality. You can go into the Schrodinger equation, you can change the probabilities before they even occur and determine whether they shall emerge as physical reality or not. The world is your apple. For God's sakes, get in there and work. Okay, what it is. What it is, it's a time reverse wave. It carries negative time. It carries negative energy. They say it has a healing property. It restores the order that where distortion crept in. And in Scientific American, Pepper publishes a beautiful picture, absolute marvelous work, showing phase conjugation of the distorted image of a cat, and the thing backs up into a nice, beautiful picture of the cat again. No problem. It does distortion correction. It moves from disorder back to order. It has negative entropy. So much for the hopelessness of the second law of thermo. They always assume positive time. Here's a critter moves in negative time. It's time reversed. And it takes care of the hopelessness of the second law and recreates hope for everybody. Now, why the hell do you age? You age because most of the stuff going on is positive energy waves. You got all those electron shells around your atoms. If you could capture the delta in the spectrographic pattern, there are spectrographic ways, spectroscopic ways of doing this very detailed wavefront analysis, usually by digital synthesis, not Fourier synthesis. Do it in impulse waves. And use one more law. Here's one from Bearden. It ain't in your textbook. Please remember this, because the previous speaker had an example of it looking at you. If you take randomness, like the virtual flux of vacuum, and you impose upon that the structured potential, the artificial potential, the scalar EM wave, very technically it produces what today we call chaos, technically. I'm not using chaos in the general sense, I'm using chaos in the technical sense. But that's a science today. But it blows ordinary science. And the chaos patterns that she showed, using 1,000th or 1/10,000th second, and then adding them, what you were doing is getting back at the digital synthesis of what's really there in the signal. Your body's been using that. Living systems has all the time. That's the way to go. She's right exactly on the track. That's exactly the way to go. Anyway, you age because of your electron shells in your atoms. But if you map the delta between the aging cells and the younger cells, and if you time reverse that delta, and if you radiate the body with that time reverse delta, you will have a signal which will move the body gradually from age back to youth. I'll say that again in case that went by you. You capture the aging pattern. That's like the Kosmoshev work. You time reverse that pattern, you have the rejuvenation pattern. And if you bathe the body and continually charge it up with that pattern, it will gradually spread out through Dr. Pop's communication system, and he discovered in the body. The virtual state is scalar, and you will rejuvenate the body. If you capture the delta in a diseased cancer cell, simply subtract the scalar pattern of the normal cell from the disease pattern and you'll have the delta. then if you time reverse the delta, you will now have the specific healing pattern for that specific illness in that specific body. It was done, it's been proven. It was called the Priori machine in France, mid-60s to mid-70s, and was ruthlessly suppressed because Priori cured thousands of cases of terminal cancers and leukemias in lab animals, done under rigorous auspices with some fine French scientists, including Robert Courier, head of the biology section and the perpetual secretary of the French Academy. The story of all of that is in my new book called AIDS, Biological Warfare, as is all the physics. There's a chapter called Extraordinary Physics, covers all this mess, and there's a chapter called Extraordinary Biology, covers all the biology. Please read that part of it because it lays a foundation for the electromagnetic healing of disease. That's the purpose of the book. The subtitle used to be an electrogravitation because almost half the book is on electrogravity. Okay. You can do some other marvelous things. Now, here's the magic one. If you make time-reversed waves, their characteristic was they do not diverge, they converge, they retain a laser-like beam. Well, if you can make, with standard practices, a hologram at 3 feet in a laboratory, by the way, this does it in real time, you don't even have to make a hologram first, with a couple of beams. This is in the literature, this is not Tom Bearden. They say very gently it's distance independent. Distance independent. Sometimes we can talk. We learned that last week. I think faster than I talk sometimes, and that confuses the tongue. But if it's distance independent, and I can do it at 3 feet in the laboratory, I can do it at 15,000 miles in the field with a radar. And it's so hard to build a scalar radar that it just takes a plumbing section and a waveguide and a switch to throw. And you get a scalar beam, not a normal beam. And if you interfere that 2 scalar beams, and you're responding, you create a time reverse wave in each beam from 2 radars in response to some signal, either passively received or reflected like from an over-the-horizon radar from a distant target. You can put a 6-inch or a 3-inch ball of light inside that target at 15,000 miles. In the latter part of November, a shuttle launch at night was the 3rd shuttle they tested these weapons against. There is the strike of such an electromagnetic missile, which I published the picture. Bob Gladwin took it in 30 lengths. There is a ball of light hanging up, which they use to switch from and shoot from, a standard artillery technique, shift from a registered point. Hanging up, seen by hundreds of people, photographed by George Sucre. I printed that photograph, and it's all in the book. They offset it so they wouldn't kill the shuttle. Now I'm going to tell you something else. 2 weeks later, we didn't react, didn't know what was going on. By the way, 12 minutes after that shuttle got downrange, there was a humongous explosion over the site, heard 600 miles up and down the coast, made the local papers, didn't make the national news, they don't know what the hell's going on. Hundreds of engineers with a whole sky blowing up over their damn heads, heard for 600 miles, said, what is that? And the standard thing was, we don't even recognize this stuff when it's used over our own head. Now, 2 weeks later, I'm going to tell you another little story because I got a new piece of data for you. The same over-the-horizon radar called the woodpecker, using time-reversed wave, real-time, distance-independent holography. All those terms come out of the literature, not Tom Bearden, only they did it with radars first. And they're doing it today. An Arrow DC-8 started down the runway at Gander Air Force Base, Newfoundland. Jet engines on, big high reflectivity, nice signal to an over-the-horizon radar. You've got your microwatt. Tesla said, I have an invisible wire. Started the interferometer, interfered with the combustion of the engines as she's taken off. They then struck that airplane with an electromagnetic missile, just like I told you about. Now let us reason together. If they did do that, the missile penetrated the airplane on one side, went right straight through out the other side, and it set fire to all of the inside at that point. All the plastics were violently and explosively set aflame. That would have had to happen. There is a hole in the right fuselage. The head of the engines was not chemical explosion because they checked it for that, no chemical residues, and there's another hole in it where it come out. Yeah, but you had to ignite the plastics. If you had ignited the plastics, you'd have had a violent outflux of orange flame. The windows would have been glowing orange out, and that was seen by 3 eyewitnesses. The interference would have been interfering with the combustion, and one eyewitness that had passed directly over his head said the engines were laboring. They did not develop full power. Everybody knows it was ice. It's been validated that they checked the ice on top of the wing, got back in the airplane before they left. That's false. And here's the clincher. If the plastics were on fire, the plastics outgas. One of the products from those kinds of plastics is hydrogen cyanide. And the people in that part of the plane would have had to breathe hydrogen cyanide and die before the airplane sunk to the ground and crashed. Now here's what the U.S. government and the Canadian government have withheld from you, and they withheld from the board doing the investigation, which is a legal offense and criminal. And they ought to be hauled into court, and who's responsible for it ought to be put in the penitentiary for conspiracy in a murder case. Now, they did autopsies on all of the remains but about 2. There wasn't enough left to do there. And about 1/2 of those people were dead of hydrogen cyanide before they hit the ground. So we've got the picture of the strike of an electromagnetic missile 2 weeks earlier. We've got the picture of the distant holography 2 weeks earlier. We've got the hole where it hit the airplane. We've got the orange glow from the fire. We got the fire, we got the hydrogen cyanide, we got half the dead people. The Soviet Union killed a damn airplane. It's a 99.9% certain conclusion. Let's continue. That's the characteristics. And let's talk about Tesla's magnifying transmitter. I want to show you quickly how it works, but I want you to know this. You know about Nikola Tesla. Everybody here knows about Tesla. We don't have to talk about Tesla to this audience. IEEE, yes, here, no. You know what he did. You know what he was building on Long Island, the famous magnifying transmitter. Take the Earth, treat it momentarily as an isotropic nonlinear medium. Hey, nonlinear, baby. Remember that word. It's going to come back to haunt us. He was going to be putting in a signal into the Earth. He had a tremendous ground plane down there. If you pump up and down like this, you pump this way into the Earth as well as pumping up into the elevated capacitance. I mean, every fool knows that, right? So, yeah, you got a signal going into the Earth. What happens to that? Well, you believe Newton's third law, right? By the way, we can derive that from this, and I found out Feynman thought of it first, and I was delighted. I had one piece missing of what happened in the nucleus until my utter, complete delight in Iranti's already worked that out beautifully and showed me last night, much to my great appreciation. So he filled in the missing piece that I couldn't find out how to fill in. Henry already had it. Okay, so we have a wave occurring in the Earth. You heard of back EMF and all those good things. That all gets generated, and it gets generated out of phase. It's a time-reversed wave. That's what causes Newton's third law. I tell you, we can derive that. I don't have time to do it. And what happens is we have then a scalar wave. It's a nonlinear medium. The back EMF, the forward EMF locked together is a zero-vector system, and that's electrogravitational. You've got a scalar EM wave now. Spherical wave goes in the Earth. You now got the pump wave. That's the wave you put in. The back EMF locked together as a single system. You got a pump phase conjugate spherical mirror Earth. Do you see that? At whatever frequency he was going to be using. And he was using frequencies at which the Earth is resonant. So you'll get a standing, scalar, spherical wave through the nuclei of the Earth. This goes through the nuclei. Don't bother with them electron shells. Like that. Well, the Earth is already highly stressed. What's stress? What's mechanical and heat stress? Every kind of wave you go in, even the mechanical stress, quantum mechanically, little electromagnetic virtual particles go in. It's electromagnetic at basis. The electromagnetic stress feeds this wave. Remember I talked about stressing the nonlinear nucleus? This is a different kind of nonlinearity, the heat stress and the mechanical stress, the electromagnetics. We got exactly the same situation, boiling like mad. It's a cathode, and it's a triode, and we're putting in the grid signal. And that whole sucker now, all the power that gets in the Earth, lots more power is in there from the amplification furnished by the Earth. It's a pumped phase conjugate mirror. As a matter of fact, self-pumped. It starts to resonate itself and builds up to a nice value. Lots of power in it. So what's going to happen, now that it's a pumped phase conjugate mirror with scalar resonance, which is what we finally get to, what's going to happen when I self-pumping? The heat and stuff is what furnishes the self-pump wave. We don't have to furnish anything but the little wave to get it initiated. When I put in a little input signal to another input somewhere else around the world here, bingo, I get back the amplified phase conjugate replica. Big amplified power. There's 1,000 papers in the literature prove pumping and self-pumping systems. They prove the amplification. They prove the nonlinearity. So if you believe those mechanisms, then it ought to be possible to do that. And you can do that anywhere, and you can power the whole Earth from the internal heat and pressure that you're tapping. And what was so beautiful about what Monteith had, he explained that all the disorder went to the electron shells, and all the order comes out on the time reverse wave, and it's beautiful. It's perfect, what he's worked out. Now, what comes out is a nice coherent wave, almost like a laser, at all these points. You could power the whole Earth with this system, except there's a little flaw with it. The Earth is not quite an isotropic medium. The Soviets have already proved, and the Westinghouse has proved, that if you use the beat frequency between two waves, the Earth will think you transmitted a sine wave at that beat frequency, and it'll go through as a sine wave and do what I've said. And the Soviets proved if you use circular polarization, you will have standing wave solutions. It's all there in the bits and pieces in the literature. So if I take the nonlinear optics work, the pump phase conjugate mirror work, the way Tesla actually built the thing, I take the beat frequency knowledge and I take the circular polarization knowledge, you can do what I had on the diagrams. And the thing will work. And you can power the whole Earth from one transmitter. And that's the secret of Tesla's magnifying transmitter. That cat had discovered what today we call phase conjugation and pumped four-wave mixing. It was workable. My conclusion is Tesla knew about it, only he didn't use those terms. He had discovered phase conjugation and time-reversed wave, and Frank Golden showed in 1985 27 such channels exactly like that put into the Earth by the Soviet Union, and I looked at it on the oscilloscope. They were 12 kilohertz apart. They were taking power out of the Earth, enormous power, 12 kilohertz, and powering that whole big system for Gorbachev in and around May Day, 1985. Gorbachev had been in power just a short time. That was the stated time they were going to be ready to have all this ready. They had stated in 1972 they made the schedule. They were using Tesla's magnifying transmitter. The Earth, Sun, and Moon are formed in a triad linked by such scalar wave resonance, and you better watch what you do on the Earth with this massive stuff, or you will tickle the Sun. And if the Sun burps and spits out a mighty hiccup of fiery molten material, you may really have the book of Revelations and the Holocaust coming at you. Don't laugh. What we looked at in and around May the 1st, 1985, if mistriggered, could have done precisely that. Every time the Soviet Union energizes these big continent busters, they risk the total survival of the human race. Now, we're going to add one law, one rule. We're going to take CPT and we're going to add all the other stuff in. Now we'll give you a new rule. It's called CPT-EGS. Charge, parity, time, energy, gravity, entropy. But now we've got a rule how to use all of it put together. The rule is, here's the normal factor. Normally we interact with electron shells. That's negative charge. Parity is normal space parity. Time is plus time flow. Energy is normal, positive energy. Gravity is the normal kind, which means attraction to mass. And entropy is the tendency to more and more disorder. That's normal physics, normal reality. But when you use time reversal, if you reverse, the rule is this: if you reverse one of those things, you reverse all of them. All the rest. Now you can do anti-gravity, you can do entropy, and you can do negative energy. If you short out a massive amount of negative energy in the laboratory, you get a brilliant flash that'll blind you for a couple of days, and the thing will freeze ice around it. It doesn't heat, it cools. Okay, Priori Lab, I want to tell you about healing cancer. What Priori did, this is his little setup he killed all the rats and the lab animals with. Up above this big coil here, there is a rotating plasma fed by 17 frequencies up in the gigahertz band. Rotating plasmas are one thing that do phase conjugation. We know today. They didn't know it in the West in 1965. And so he has a rippling magnetic field, strong magnetic field, which by magnetic resonance will get him into the nucleus of all the atoms, by nuclear magnetic resonance. Why the nucleus? Because he's got to get down where the negative energy stuff and the negative time stuff is and electrogravity is. That's where the control system of the immune system and the living systems are. Living systems have had to use negative entropy to keep producing the same kind of species pattern. Otherwise, the law of entropy would eat them alive after about 3 generations. You couldn't transmit the pattern anymore. There wouldn't even be species. You have to use negative entropy. And that's why living systems use negative energy, negative time, and scalar waves. He produces then a phase conjugate pattern. He's learned what the right mixture is to give him the anti-pattern for that cancer. It comes right back down through, gets down into the bone cells, everything else, bathes every cell in a little animal, and reverses to cancer. If you de-differentiate, a cancer cell turns back to a normal cell. Now, Robert Becker should have the Nobel Prize for proving how little weak picoamperes of current heal bone. It takes the red blood cell, shucks off the hemoglobin, the thing regrows the genetic nucleus with all the genetics, turns into that kind of cell. That's called de-differentiation, going back to a more primitive cell. That ain't what's needed, so it then crawls around and turns into the kind of cell that makes cartilage. That ain't what's needed, so then it crawls around and changes into the kind of cell that makes bone and heals these horrible bone fractures. And he proved that in vitro with frogs after he'd healed bone, terrible bone fractures. Should have a Nobel Prize. Nobody had the foggiest notion it was the red blood cells responding to picoamperes of current. Tiny current, so small you can hardly measure. Can you not do picoamperes with this thing in the body? Of course you can. Can you not drive cells through that whole structure? Of course you can. You can do electromagnetic healing of any kind of cellular disease known to man. You don't have to understand the cause. You just got to capture the delta. Can time reverse it and do that to the body and you'll cure it. And that's why they wiped out priori. And that's why they suppressed that machine, because a dead cancer patient is $167,000. Multiply that by $500,000 a year in the United States, and you'll see why they don't want to cure cancer. So how are they going to cure AIDS? They're going to give it to the same bunch that's refused to cure cancer for all these years. How many AIDS patients are going to die before they do this? This is proven. It worked. It's real. It's still in the French hardcore medical literature. There's no reason for these 500,000 people dying every year, and for the AIDS people dying. $100 million and 3 years will cure all of those diseases. They're not going to spend it that way. They're going to give it to that crew. You can't make a vaccine, and they're going to spend billions and bankrupt the whole medical system, and they're not going to cure it. That's the way to cure it. That's my new book. Thank you for your attention. Drink of water. Andrea Puharich once accused me of sounding